everyone. Thank you for being here today. We're going to talk about making our math instruction more meaningful by using the method task, question, and evidence. We all are looking for meaningful instruction, and this is going to both increase our rigor and it will also increase our student engagement. So today, our goals are to help you understand what the TQE, the background of why we're doing it, understand what the process is, and begin to understand how to create a meaningful task. So first of all, some background into why this is a good method. We know that our students are lacking in conceptual understanding of mathematics. They are able to solve a computation problem, but then when they're asked about what those numbers represent or why they're doing what they're doing, that's when we were having a problem with where we could tell the students were not understanding at a deep and conceptual level. So we've also noticed that our teachers are having to reteach skills that were previously taught because of lack of mastery. So both of those things together made us decide that this was going to be a great method to use. And so that's why we're introducing it to you today. Our goal is for our test scores to be high, but our student understanding to be just as high. We're not doing this simply for a test. We really want deep student understanding. So first of all, what are procedural skills versus conceptual understanding? Our procedural skills means that a student is proficient at using a mathematical algorithm to solve a problem. But our conceptual understanding means that the student is able to not only compute and get the right answer, but to explain why they use that method and to explain what that answer means in terms of what the problem asked. So they should know what the number that they got represents in terms of the situation that was given to them in the problem. So let's walk through a traditional math lesson. We all learned in college at some point in our teaching career, maybe at a pre-service, as a pre-service teacher, the gradual release model. So I do, the teacher demonstrates how to solve a problem. So the teacher provides strategies. First you do this, then you do this, finally you get your answer. Then we went to we do. The students mimic what the teacher did. They follow that same method to get the correct answer. The teacher is checking for correctness at this point. That is the teacher's way to monitor student understanding. And finally, after they did the we do, maybe that was a group work, maybe that was on the whiteboards, then we release the students to work independently. We call that the you do. Again, it's individual practice of teacher-selected problems, and we're looking for the student to be able to follow the method to get the correct answer. Now the task, question, evidence math lesson flips that on its head. So what we're doing with this lesson is we give students a meaningful task. This is a math problem that is a word problem. It's situationally based. So the students engage in problem solving at a task that is aligned to your standard and learning goal. So you give a group of students a task. As they are working, the teacher is walking around noticing individual thinking and asking questions to better understand why the student is solving that in the way that they are solving it. Your goal here is to have an understanding of what their method is. And as the student works, they're creating evidence of both their conceptual understanding. A lot of times that evidence is going to come verbally from what they're saying, and they're also giving you evidence in terms of can they solve the problem with this method. You're looking at both the physical mathematical evidence on the paper and the verbal communication skills as your evidence for student understanding. We all know as teachers that we plan these amazing lessons and we expect them to go in this perfect straight line. I plan this, then we're going to do this, then we're going to do this. It never works out that way. So this TQE method is designed in a way to harness that feeling of, oh no, things are kind of going awry, and that's part of it. We want things to kind of open up, and then we're going to, as the teacher, bring it back together. So let's talk about how that happens. First, we start with a task. Again, this task is based on what do you want the students to learn that day. So you give them the task, and in ideas. They go in a wide variety of areas. We have some that are right there, they've got this great idea, and we have some that are so far down below that target that they're not where they need to be. And that's a moment as a teacher that first it's very intimidating because you know that you want the student to meet the objective. But instead of, which is maybe our first instinct, coming up and showing them, you're going to use questioning to get those students where you want them to go. You're going to notice that the teacher questioning line comes all the way through the line because that's something that you're continually doing. As you're walking around questioning students, you're pulling student examples. So you might have an example that is a strategy that you think is an awesome thing to share with the class. What we know is that if students know that ideas are coming from their peers, they're much more likely to be engaged with it. So by showing our students, Mary has a great idea. This is what's happening right at this point. You're bringing your class back together and not only having the evidence of the understanding for yourself, but you're sharing that evidence with your students so that they are truly learning from one another. That really puts that mode of importance really on the kids. You are not the one that holds all the math knowledge. You're getting all of your examples from your students. Look at this. What can we think of? What does this method tell you about what Mary's thinking? Look at this. What does this tell you about what Sally's thinking? Mary and Sally might not be right, but maybe it's going to lead you to another question that you could ask. So based on what Sally was thinking, what can we do to make sure that we're XYZ based on whatever your task is? As you have them come back together and start looking at the evidence, and you continue to ask questions of the whole class about what is happening, that's when you're bringing your students back together to get them towards this learning goal. So even though they started out with a great differential as far as what they're understanding, our goal is to bring them all back together to harness in the understanding of that task. In the state of Florida, we have mathematical practice standards. These standards go alongside every grade level, K through 12, beside the content standards as far as what the state says students should be able to do in terms of mathematics. So there are 8 of these. We have found a way to tie these into TQE because we want to know where are your students using those mathematical practices. So in the task that you're given, this is where your students are making sense of a problem. You as the teacher are not standing at the front of the room explaining the sense making and doing that for them. You're putting that sense making onto a group of students. Can they persevere? If we never give our students challenging problems, we're never building that perseverance because they've never had to work through anything that was a challenge. Students are creating models. This would be any time that your student is given a task and they're drawing a picture, they're drawing a thinking map. These are all models. Attend to precision. This is our point in math where we want to get our answer correct. So in order to get our answer correct, we need to carry the one, we need to add and subtract correctly. All of those things we have to be precise about. And finally, can they look for and make use of structure? So within the problem, is the student able to figure out the mathematical structure and use that in order to solve it? As a teacher, you're collecting evidence. Is my student able to reason abstractly and quantitatively? You're going to know that quantitatively is the answer correct. Abstractly, is the child able to conceptualize the math, put it in terms of the question, and are they on the other side of that able to deconceptualize it? Are they able to tell you what that number means both in math in general and in terms of the question? Your students are going to be constantly talking to each other. This is group work. So through that, you're going to be able to hear them construct an argument for why their method is correct and support that argument with their reasoning. And can they look for and express regularity and repeated reasoning? Again, they're being able to reason over and over. Here's why this makes sense. They can listen to the reasoning of others, and they're able to continue to make sense of that work. So, We talked about our triangle. We open things up with our student ideas going both ways, and then we bring it back together with our evidence. This just kind of gives you a visual about where those mathematical practices, you might start to see them in your classroom. So when we first get a task, that's when all of our students are working on making sense. Some of them are making sense at a high proficiency level. Some of them are making sense at a much lower proficiency level. They're all starting at different places. This is our method to really meet them where they are and support each individual student. When you bring your kids back together to, again, look at those student examples, this is a great opportunity for students not only to give reasons why they think that's a good example, but if we look back at our mathematical practice, one of these was critiquing the reasoning of others. We don't give our students a great opportunity for that if we are standing at the front telling them what to do. But if we're presenting, so this is Sally's idea, we're giving students an opportunity to say, well, I'm having trouble understanding X, Y, and Z. That is giving them that chance to practice those skills of making sense of not only their own work, but their peers' work as well. And they're having to express themselves verbally, mathematically, as well as maybe even writing their examples. So let's talk about our look-fors. So we're telling you that you're gonna give kids a task, they're gonna work on it, and you're gonna walk around and collect that evidence and ask them targeted questions. What might that look like in a classroom? So some questions you might be having right now: what task are students being asked to engage in? What questioning techniques is a teacher going to use? And what evidence of students' conceptual understanding is going to be collected? These are going to be questions that we're answering in this next part of our presentation. We're also going to look at a sample task to show you some of these as well. So, what is the teacher doing? Again, going back to our old. So what is our teacher going to be doing? We know, going back to that gradual release, we're used to seeing the teacher standing up front. I am the holder of mathematical knowledge and I'm going to explain what to do. That's no more. We're now looking for a teacher to serve as a facilitator. We know that the students have the capacity to solve problems. We're here to help and guide, but not to give all of it right away. So your goal as a teacher, what you should see, is someone posing challenging tasks for students to use to practice that sense making. We're going to see teachers asking questions to gauge individual understanding. So you might see a teacher walk up and say, why did you use this strategy? Explain it to me. That's going to help that teacher to understand where that student is as far as understanding. And they're facilitating learning through whole class instruction using student examples and student thinking. Henry has this example. Henry, can you explain to us why you used this sample and what you're doing here? What did this mean? Things like that. What should you see the kids doing? The great thing about this method is that it is not a passive classroom. Our students are actively engaged. They're the ones doing the work. So you're going to see kids working collaboratively, maybe a pair, maybe a group of 3 or 4. You're going to see kids describing why they agree and disagree with our peers. Again, our goal is to build in those mathematical practices, which one of them is that they're able to defend their own argument and critique the arguments of others. And we're going to see kids writing and verbally communicating to explain their mathematical strategies. It is no longer enough that they can get the correct answer. What we want to understand is that they know why they're doing that and how it's going to help them get answers correct in the future. We cannot prepare our students for every question that they'll ever face. So by giving them this toolbox of perseverance and deep conceptual understanding, we are better preparing our students for the future where they are going to be facing all kinds of tasks. And what's our content going to look like? First of all, it's standards-based, so you're pulling your learning goals directly from the standard. Our content is that high depth of knowledge. We're not looking for short computation problems here. We're looking for deep, meaningful, high depth of knowledge. And our student-led learning tasks. Again, this is all about student engagement and teacher facilitation. So let's look at a sample task. from our state site. It came from CPALMS, from the Florida Department of Education, and it's just a great look at using your resources that you already have and twisting your instructional method. So, in this problem, we have our students, there's 72 students, 12 chaperones, and 5 teachers on a roller coaster. If it carries 9 people, the teacher wants to know how many trips the roller coaster will have to make for everyone to ride. So it gives students a chance to, an opportunity to solve to find that out. So again, we should see our peers working, solving, and describing in words why they're doing this. The task then asks the kids, how many people were on that last trip on the roller coaster? Was it a full car? How do you know and why? And then finally, and this might be your extension piece, if there were 11 minutes for the coaster to load, to ride, and unload, how many minutes will it take for the whole thing, everyone to ride on the trip? So you can see how this task lets you really dig into where your kids are. It gives them multiple opportunities to learn from one another, to explain their reasoning, and to continue to grow as mathematical learners. This task planning sheet is attached to your presentation, and it just walks you through some of the steps for your task as you're thinking it through. So, what is my task? I want it to be a high cognitive demand task where my students are engaging in the mathematical practices. As a teacher, it's important to reflect on your questions ahead of time. How are you going to, if a student is doing one thing, what are you going to ask to get them to the next step? Remember, you're asking, not telling what to do. And evidence. What kind of evidence are you going to collect of student understanding? Are you going to collect evidence from their verbal explanations? If so, how are you going to make sure that you're monitoring that in a way that you can remember it later so you can use that data to make groups, to reteach, things like that? So, again, this was just a brief overview of our task question and evidence model that we're using here at our school. Our goal is to, again, to create meaningful lessons where our students are highly engaged and then they are deeply understanding mathematics. Thank you for coming.